Hello everyone, in this video we are going to understand and derive section formula. So let us consider a line segment AB which is getting divided by the point P in the ratio of ms to n. So let's mark the coordinates of AB. So A is x1 comma y1 and point P is x comma y and point B is x2 comma y2. So you can see that the point P is dividing this line segment in the ratio of ms to n. Yes. So we can derive the coordinate of point P with the help of section formula, which is given as x comma y is equal to x2m plus x1n divided by m plus n comma y2m plus y1n divided by m plus n. Now let's see how the derivation works. Okay, so for that let us consider two triangles, which is PBD and APC. You can see that triangles have been highlighted. Yes. Now let's write the values of each thing. Okay, so what is BD? BD is y2 minus y. You can see that point B is having y coordinate as y2, but we are interested in finding out BD distance only. So I will write y2 minus y. Similarly, if I want to find PC, I will write y minus y1. Is that clear for all? Next, if I want AC, x minus x1, and if I want BD, I will do x2 minus x. You can see that these two triangles are similar by AA criteria, where angle P and angle A are equal, corresponding angles are equal, and angle D and angle C are equal, which is equal to 90 degree. So I can write these two triangles are similar. If they are similar, I can write the ratios by Cbse. Yes, which is BD by PC, which is equal to BP by AP, which is equal to PD by AC. Yes. Now let's put down the values for each and everything down. So y2 minus y1 by y minus y1 is equal to n by m, which is equal to x2 minus x divided by x minus x1. So you can see that the value of BD is y2 minus y1, PC is y minus y1, which is equal to n by m, which is BP by AP, and which is equal to x ratios PD by AC, which is x2 minus x divided by x minus x1. We are going to just equate and derive the section formula. So let us consider this x2 minus x divided by x minus x1 equal to n by m. Just cross multiply. If you cross multiply, you will get m into x2 minus x, which is equal to n into x minus x1. On further simplification, just multiply m inside, you will get mx2 minus mx, which is equal to, again multiply n inside, so you will get nx minus nx1. Yes, bring x to one side and keep the rest on the other side. You can bring this one to the right hand side, and you can take this nx1 to the left hand side. Yes, if you do like that, you will get mx2 plus nx1, which is equal to nx plus mx. You can see that x is common. Yes, so let's take the x out. X into m plus n equal to mx2 plus nx1. x is equal to mx2 plus nx1 by m plus n. Yes, so we got the coordinate of p x, which is abscissa of p, and if you repeat the same derivation for y coordinate, which is the ordinate of p, you will get y is equal to my2 plus ny1 by m plus n. Yes, thank you.